Right, so we're going to look at quadratic identities, which is really a simpler version of what we've done in polynomials in chapter 12, way back at the start of the year. Just applying it more basic forms. So let's have a look. Examples. Right, so if 3x squared plus 4x plus 2 is equivalent to ax outside of x plus 1, sorry, take away 1. This is on page 71 in your notes. Plus b, x plus 1 plus a capital C. Alright, so we need to find the values of a, b and c. Alright, do you remember doing this in extension?
I do.
Not the ABC.
I do.
I remember the ABC.
I remember it.
Yep.
No, you don't.
I remember it.
Do it. Do you want to get up? Do you want to
I
get up
could
there and show us all?
You just expand it, and then you collect like terms,
Yes.
and then whatever that equals with that term equals that term.
Good. Alright, so the right hand side. So let's expand that right out.
Oh wait.
Alright, ax squared, take away ax plus bx plus b plus c.
Did we do it with different terms?
And now we're going to factorise in like powers of x. Okay? So equal, there's only one x squared term. We have two terms with x's with it. And we also have two constant terms without x's with it at all. Alright, so take away a minus bx, or you can write it as a plus b take away ax. It doesn't matter, you get the same answer. Plus the sum of b and c. And then we need to match it with your like powers.
Is it going to be that formal like every question?
Not necessarily every question, but yes, most of your questions you'll expect this sort of thing. Okay, so once you factor over your like powers of x, 1, you've got to match it with your like powers back in the original question. So this part will be 2 because it's x, and then the like powers of x for your question. 3 and 3.
Would you?
Okay,
Wouldn't it just be easy to make it a positive, like plus b take away a?
it's up to you.
'Cause it's a positive.
Go for it. Go for it. Be adventurous.
Good idea.
Go the other way around and show you to get the same answer. There's that. Right, so x squared, ax squared must equal 3x squared because we've got equivalency happening here. In other words, they're equal. Alright, so capital A is 3. So remembering, you're going to use previous parts of it to answer the next section. So, we've got the x term here, what we just worked out, and then we need to go back to the original question. So we have positive 4x, so negative outside of A, take away B. For the x must equal the coefficient of x back in the original question. So whatever way you do it, you just got to be careful with your sign.
It'd be easy to do the other way.
Hey,
It'd be easy to do the other way.
yeah, says you.
Oh, I'm done.
Alright. So in other words, A take away B is negative 4, so moving the negative sign over the other side. And of course, we've already established that A equals 3. So 3 take away B is negative 4. So 3 take away what equals negative 4? No. Just 7. Okay, so you take away 3, so negative 7 here, but you've got negative b equals negative 7, and the two negatives cancel out to positives. And then the constant term, b plus c, must equal the constant part back in the original question. So, b plus c equals 2. And we of course know what B is already. So C equals
Why did it take so long for
-5.
Don't do this too tricky.
Did you notice that a lot of access questions like that? Yeah. What's 1 plus 1?
Alright. B. Express 4x squared take away 1 in the form A outside of x plus 1 squared plus B x plus 1 plus C. Okay, so word is slightly different, but we're performing the same things we've done in the first part of the question.
Have to be capital?
Hey?
No.
Nope. Put whatever letter, caps, lowercase, whatever.
Just don't use
They could go to the Greek alphabet, they could do all sorts of things they really want to do there, okay, but typically you're going to get A, B, C's for this one. Alright, so in other words, 4x squared take away 1 is equivalent to A x plus 1 squared plus B outside of x plus 1 plus C, and we're doing the same thing we've done over here, okay? So the right hand side, so expand it right out, and then we're going to factorise in light powers of x. Right, so task number 1, you expand it right out, and then once you've done that, you factorise with like powers of x. It's very easy, compared to extension. Some agree. Right, so we only have one term involving x squared. We have 2 terms with x's and 3 terms without any x's associated with as well, so that's what we need to factorise. Right, so ax squared, so we've got a 2ax and a bx, so 2a plus b outside of x,
B doesn't have a 2 in it, so you can factor
plus a plus b plus c. And then we need to match it back to the coefficients in the real question. So, ax squared must equal 4x squared if it's equivalent. So a must be 4. 2a plus b, the coefficient of x, must equal the coefficient of x in the original question, which equals what? 0, because there is no x term there. Alright, so of course we know a is 4, so 2 lots of 4 plus b is 0. So a plus b equals 0, so b must equal -8. A plus b plus c equals what? -1. Okay, so the constant term must equal the constant term, including signs, when we match it out. Alright, so for take away 8 plus c is equal to -1. So -4 plus c is -1. C must be 3. Going back through the equations work. Alright, there is another question in the theory note, but I've actually got to sit down and work it out myself, so we'll do part 2 when I work this out next lesson, for next lesson, sorry. Are there any questions in this concept?